Over there, there's the moon on the left, Vince. Where's the steering wheel? Just there. Dumb brain. It's not in gear. Yes, it is. Shut up, Creamcake. Hi, Vince. Today we're going to talk about one of the most influential scientists of modern time. Who's that then, Creamcake? A scientist named Irwin Schrodinger, Vince, concerning a thought experiment he proposed in 1935 about a cat, which became one of the most talked about thought experiments ever in the history of science, and which became to be known as Schrodinger's cat. I don't like the sound of that, Creamcake, because cats eat cakes. Yes, I had not thought of that. No, shut up, Vince. It is not a real cat, merely an imaginary one. Hey, why is the background a custard colour? You know I hate custard. Yes, but mince pies like you go well with custard. OK, smartass, back to Ernie, and tell me exactly what is a thought experiment. Well, firstly, his name is Irwin, not Ernie, you dimbat. Wombat. Cricket bat. Bat face. Look, shut up, Vince. A thought experiment is merely an exercise in thinking and discussing what-if sort of scenarios where nobody knows the real answer, and so whatever idea you come up with, you can never be proved wrong. Cake face. Face ache. Face moon. Moon saucer. Saucer chops. Look, shut up, Vince. Now, here's an example. You might conduct a thought experiment about what will the civilization be like in 1,000 years' time, or what would seasides be like if the moon disappeared, because the moon controls the tides? Oh, I see. Yes, maybe. Mankind has been destroyed by nuclear weapons. Or mankind has moved to another planet in the galaxy. Although I tell you what, Creamcake, the moon had better get his act together, because I love the seaside. Yeah, I think you have the general idea. Oh, ouch, what was that? Damned apples. Ouch! Oh, I know what's causing them. We were going to meet Isaac Newton because an apple fell on his head, but he's currently on a trial for Liverpool Football Club. Wow, a 400-year-old footballer. By the way, those apples have stopped falling now, Professor. Yes, indeed they have. Ouch! Ow! The thought experiment we are going to discuss was proposed in 1935 and is merely a scientific thought experiment about a cat and quantum mechanics. Quantum what? Quantum mechanics, Vince, deals with the study of subatomic particles and the like. And, you know, unlike larger objects, they behave in a very strange way indeed. That sounds cool, but where does the cat come into all this? Well, actually, it is not a real cat, but an imaginary one, and is part of a thought experiment Irwin made up in 1935, which helped challenge contemporary interpretations of quantum mechanics, particularly the Copenhagen interpretation. Why would he want to do that? Well, Vince, he wanted to highlight to cream cakes and mince pies like your good self the dangers of applying laws and theories of quantum mechanics to much larger objects. So, tell me again, Professor, what exactly is quantum mechanics? Vince, it is a vast and complex subject. Look, if you offer me a deck of cards and I choose a card without looking at it, before I look at it I know that it is either a red or a black card, and when I turn the card over to find which colour it is, it merely confirms the reality of the situation, i.e. that it is either a red or a black card. I don't like cards. Oh, hey, do you want to play Patience? You dumpling, you play Patience on your own. Actually, you are trying my patience right now. Oh, are you sorry, Professor? Now, look, subatomic particles and the like do not act quite in the same way as large objects do. Go on then, smartass. Look, if we think about subatomic particles like an electron, well, unlike the card experiment, we can never be quite sure of its state before we look at it. You see, Vince, in quantum mechanics, the only thing you can know about the electron's attributes beforehand is that it is in a fuzzy electron cloud around the atom and is therefore sort of in more than one place at the same time. Is described by scientists as the object being in a state of superposition. Wow! Now Vince, what do you know about radioactivity? Yeah, it's harmful rays or particles being emitted from an atom which can be measured by means of a Geiger counter. Yes, correct. Did you know even bananas are very slightly radioactive due to an isotope of potassium they contain? Now look, my learned friend, there are 3 types of radiation: alpha, beta and gamma radiation. My learned friend indeed. Please don't talk to me in that stupid way, Mudface. Quiet in the ranks. Vince, if you were to put one atom of a radioactive element which has a 50-50 chance of spitting out a particle in the next hour in a steel box together with a cat and a Geiger counter connected to a phial of cyanide in such a way that when and if the counter detects an emission, a hammer will make the phial break, releasing the cyanide, and the cat dies. Hey Mush, even though I hate cats, and Arnie or whatever his name is kills a cat, I will get the RSPCA and police onto him. No Vince, remember this is merely a thought experiment proposed by Irwin Schrodinger to challenge contemporary thinking about quantum mechanics, and no cat is harmed in any way. You see, according to the Copenhagen group way of thinking, the thinking is that, unlike the card trick explained earlier to you, where you know the card chosen is either red or black before you look at it, looking at it merely confirms your knowledge that it was a red or black card beforehand. Well, in quantum mechanics, things are not quite like that, you see. You see, the particle which may be spat out from the atom inside the box can only be thought of as a mathematical wave function and is thus interpreted as being in a superposition of quantum states, like I mentioned earlier, or in other words, being in more than one state at the same time. Okay, do you understand that? So the particle is emitted and not emitted, if you like, at the same time. We can only describe its reality before opening the box as it being in a state of superposition. Now, it's only when you open the box can you confirm that a particle has been emitted or not, because then obviously the wave function which describes the state of the particle no longer applies, because you can see whether the thing's been emitted or not, because if it's been emitted the cat will have died, and if it's not been emitted then the cat will live. So what, Professor? Hey, just remembered Wales are on telly, playing the World Cup semi-finals. I know, Vince, but they don't kick off for another 47 minutes. OK. Good. So, Professor, what about the cat? If the Geiger counter detects that the particle has been emitted from the atom, then on opening the box, you will find a dead cat or otherwise. If it has not been emitted, you will find the cat still alive. That is correct, Vince. You see, the quantum mechanic interpretation is dangerous because it suggests that the cat is in quantum entanglement with the particle because its fate depends on the state of the particle, which is in a state of superposition, meaning it can be in more than one place at the same time. Therefore, as the particle's attributes can only be thought of as a wave function, then the cat too must also be looked upon as a wave function, or being in more than one state at the same time before the box is opened. The implications of this are that because the cat's life depends on the state of the particle, it implies it is in a state of quantum entanglement with the particle before the box is opened. In other words, you are led to conclude that the poor Moggy is in a state of superposition, meaning that it is both alive and dead at the same time. Clearly that is absurd. Yes, but if you believe that, and you can't see inside the box, then the cat may indeed be alive or dead at the same time, as no one can prove you wrong. Yeah, that is correct, Vince, I'll give you that. But most people will believe that being alive or dead at the same time is impossible. Although when I look at you, Vince, it makes me wonder sometimes. Well, look, Creamcake, if I agree with you,
that the idea of the cat being alive and dead at the same time is impossible, then there must be some size boundary where objects can no longer be thought of as being in a state of superposition. Because to describe the cat as being alive and dead at the same time is, as you said, ridiculous. Hey, Creamcake, yes, this is interesting. Tell you what, I want to be a particle physicist and do a PhD.
Oh, heaven forbid. Yes, Vince, that would be great. I'll believe it when I see it. Bye.
Bye.